Welcome to my channel Mathematical Clinic of Subash. Today we are going to discuss the word permutation and combination. Actually, in the last videos we learned that I'm going to take one example. How many words with or without meaning can be made using alphabets A, B and C without repetition. We learned that this work can be done by 6 ways, cause if you fill 3 places with the word A, B and C, then for this place 1 you have 3 choice, cause repetition is not allowed. For this place 1 we have 2 choice, and for this place 1 you have only 1 choice. And by the multiplication theorem of basic principle of counting, total number of words can be made becomes 2 3 6 into 1 equal to 6. Now here we are going to write all those 6 words which can be made using alphabets A, B and C. Actually there are 3 types of words, one starting with A, another starting with B and third one starting with C. Here A has come, so you are left with B and C. Here B is there, so you are left with A and C, and in this combination one you are left with A and B. Here AB has already come, so you are left with C. AC, that is why you are left with B. BA, that is by C. BC, that is by A. CA, that is by B. And CB, that is by A. So the first word one is ABC. Second word one is ACB. Third word one is BAC. Fourth one is BCA. Fifth one is CAB. And last one is CBA. These are the first, second, third, fourth, fifth and sixth words that can be made using alphabets A, B and C. Now we are going to discuss whether there is order in the component of this arrangement or not. Actually, we can see that this particular arrangement result can be obtained from this result by interchanging B and C. If you interchange two components B and C in this particular result one, then this result will come. And let us see whether this result come is different than the last result ABC or not. Of course, because it is a word ABC word and SCB word is the different word one. So here we can see that if any two component of the result is interchanged, the new result so come is different than the given result one, ABC one. It means there is order in the component of this result one. It means while making words from some alphabet, making words means if you are interchanging the position of any two components, any two alphabets there in the word, then the new word is going to come. It means there is order in the component of this result one. Actually, I am going to the conclusion that this work can be done by 6 ways with regard of order. It means having the order in the component of in the arrangement ones. Then this 6th one is called the permutation. So in conclusion, we can say that while making some objective results from some given objects, the number of ways by which it can be done with regard of order is called permutation. While making odd objective result, first, second, third, oddth places, if you are filling odd places from n given object x1, x2, x3 and xn, y regards of order, this type of arrangement one, it means with regard of order means if you are going to interchange any two component, then the result coming is the different than the previous result one. So while filling n places, while making n objected results from n given object, the number of ways by which it can be done with regard of order is called permutation, and it is denoted by Vn semicolon r or npr or simply Vr. So NPR is the permutation of n given objects taken r at a time. It means the total number of arrangement results having odd objects can be made from n given objects with regard of order. Don't forget, the matter is of the order, having order or not order. If there is no regards of order, then the number of ways by which it can be done is called combination, and that is denoted by Cn semicolon r. Combination of n given objects taken r at a time, or NCR, or simply CR. So we came to the conclusion that the number of ways by which r objective results can be made from n given objects with regard of order is called permutation. If there is no regards of order, then it is called combination. You must remember the word order. For example, if you are making number, consider a number 123. If you are changing the positions of any two component 2 and 3, then it becomes 132. This one is different than the previous result one. Here, if you interchange any two component in a single result, then the new result come is different than the given results one. It means there is order in the components. So making a number is a work of permutation. Making a word is a work of permutation. I'm going to take another example. For example, you are going to make a committee of 4 people: Ram, Syam, Mohan, and Meera, from 10 given people. Actually, consider one committee. This one is the committee consisting of Ram, Syam, Mohan, and Meera. Let us interchange the position of anyone. Let us take Meera at this place, Ram at this place 1 and Meera at this place 1. So the committee will be here Meera, thereafter here Ram, here Syam, here Mohan. Is this committee different than this committee one? No. This one is same as this committee one. So to constitute to make a committee from some people is the work of combination rather than the work of permutation. Cause even in interchanging two component among them, the results will come. The new result come is not other than the given result one, same as the previous result one. So there is no order in the components one. No order in the component one means this is the work of combination. That is why to make a number is a work of permutation, to make a word is a work of permutation, to make a committee is the work of combination, to make a team of players is the work of combination. You must think whether there is the regards of order in the components in a particular result or not. If regards of order, it is the permutation. If no regards of order, it is combination. Okay. Now we are going to establish some formula of the permutations and combination. The first theorem one is we are going to find the permutation of n given objects taken r at a time when the repetition of object is not allowed. This is the case when all given objects are different and repetition is not allowed. Actually, here you are given with n objects. Suppose the objects are x1, x2, x3 and so on up to xn. N objects, n given objects, and how many places to be filled? R places to be filled. First place, second place, third place, up to rth place. This one is first place, this one is second place, this one is third place, and finally rth place. Repetition of digits is repetition of object is not allowed. So let us begin with here. How many choices are there to fill this place one, first place one? You are given with n choices. So this place can be filled by n ways. Cause repetition is not allowed to fill the second place one. How many choices will remain? One choice you will reduce and you will be left with n minus 1 choice. For the third place one, n minus 2 choice. Finally, for the rth place one, you can consider here. For the first place, n minus nothing than 0. 1 then n minus 0, 2 then n minus 1, 3 then n minus 2, here r then n minus r minus 1, 1 then minus 0, 2 then minus 1, 3 then minus 2, then r then minus r minus 1, or simply you can write it as n minus r plus 1. So we can again see from the beginning. You have to find the permutations of n given object, x1, x2, x3 up to xn are the given objects taken r at a time. It means you are going to fill r places first place, second place, third place, likewise up to nth place 1. When the repetition of objects is not allowed, it means once an object used here cannot be used at the another place 1, second place 1. That is why the first place can be filled by n ways, because you have n choice for the first place 1. Second place can be filled by 1 choice reduces, that is why n minus 1 ways. Third place can be filled by n minus 2 ways, and like that if you generalize, 1 then n minus 0, 2 then n minus 1, 3 then n minus 2, r then n minus r minus 1, that is n minus r plus 1 ways. Hence, by the multiplication theorem of BPC, basic principle of counting, permutation required permutation becomes Pn comma r becomes product of all the choices, n into n minus 1 into n minus 2 up to how much? N minus r plus 1. This is the answer. To change this result into a standard form 1, I am going to use algebraic technique here. Here n as it is, n minus 1 as it is, n minus 2 as it is, continuously up to n minus r plus 1 as it is. I am going to multiply this result by what number follow this number 1? N minus r. This 1 minus 1 equal to n minus 1. After 1, which number will follow this one? It becomes n minus r minus 1 continuously up to 3 into 2 into 1. We have multiplied the result come by the product of n minus r up to 1 continuously. If you do so, to balance the result 1, to make the same result, you have to divide by the same number. It means you are going to divide also by n minus r into n minus r minus 1 up to continuous product up to 1. Actually, this will not damage our result 1, because if you cancel n minus r will cancel, n minus r minus 1 will cancel, all the terms after this term 1 will cancel, and you will be left with same thing, n into n minus 1 up to n minus r plus 1. That is written here. I have done this one to convert the result into a standard form. Now you can see that here the number begins from n, continuous product up to 1. That is the definition of factorial n. By the same manner, here the number begin from n minus 1, result begin from n minus r, and continuous product up to how much 1. This can be written as n minus r factorial. That is why we came to the conclusion that in this case this case means when all the given objects are different and repetition is not allowed, the permutation becomes Pn semicolon r becomes n factorial divided by n minus r factorial. So we come to the conclusion that permutation of n given objects taken r at a time is n factorial divided by n minus r factorial. When all the given objects are different, when all the given objects are different and repetition is not allowed. Repetition is not allowed. Next one, let us replace r by n. Replace r by n in last result one. What happens? It becomes Pn semicolon, in place of r it is n. This becomes n factorial as it is, downwards n minus r is n factorial. This becomes n factorial divided by n minus n equal to 0 factorial. As you know, 0 factorial is 1, so the result is n factorial. That is why we came to the conclusion that permutation of n given objects taken all at a time. Permutation of n given objects taken all at a time, when all given objects are different and repetition is not allowed, is n factorial. It means if both the components are the same, then the value of permutation becomes 1 components factorial if all given objects are different and repetition is not allowed. We are going to do some of the numericals on the basis of this result one. The first question is, by how many ways can 4 people be seated on 7 seats in a row. Actually, the question is quite clear. There are 7 seats. 1, 2, 3, 4, 5, 6, 7 seats in a row. And how many people to be seated? 4 people. 1, 2, 3, 4. 4 people to be seated. Now you can say, uh, which one is n? Actually, number of seats is 7 and number of people is 4. You know that r cannot be greater than n. In this formula 1, the r cannot be greater than 1. It means r is less or equal to n. The maximum value of r can be equal to n or less than n, but r cannot be greater than n. So here we can see that all the seats are different, even all people are different. One people sit here cannot be seated at there, that is why uh, here the condition is matching for this theory one. Condition matching means all the given objects are different and repetition is not allowed. So simply we have to find what is n and what is r. The greater one 7 is the n, the smaller one 4 is the r. Now we are going to find the value of Pn comma r. Pn comma r will be P7 comma r. It is not 7 comma r, 7 comma 4, and it is by this formula 1, 7 factorial divided by 7 minus 4 factorial. The result becomes 7 factorial can be written as 7 into 6 into 5 into 4 into 3 factorial divided by 7 minus 4 equal to 3 factorial. 3 factorial will cancel, and you are given with the result here.